All right, welcome to statistics. So what we're going to do is we're looking at, I'm going to use some box and whisker plots here to kind of distinguish between tighter range values versus a higher mean within a data set. And we're just going to go under the assumption that these data sets are going to be on the same grid. All right, and I'll create one here like this, and we'll put, say, so we have our min, there's Q1, our lower quartile, so this right here would be 25% of the data, of course. And here's another 25%. Here's our mean, which I'll call X bar. Here's our third quartile, and here's our max, right? Now, if you're wondering where's Q2 at, and the mean right here is Q2, so there's that value, right? Now, let's just say that we have a second data set, and it looks more like, say, this. All right, and again, you have your minimum, you have Q1, you have X bar, and you have Q3, and then you have your max, all right? And let's just say this is all on the same data set. So this is all real rough, but just going to give you values here. Now, when I'm purposely engineering these values to have a particular behavior that I want them to have. All right, and that being, I want to look at the difference, whether, what does it mean in a data set when we have a high range value versus all the values are really close together? What's the difference between those two instances? So, and actually I mislabeled that. This isn't the mean. That's my fault. I apologize. This is the median. All right. So when we look at the data set, same thing for this one down here, this would be Q2, would be the median. So when we look at this data set and we're trying to decide, what does this mean? It means that half the data is below this and half the data is above this. So versus this set over here where the data is much more closely, the range of values here, that's what we're talking about is when we talk the range of values. This is, let's just say, let's call this is 2, this is, call that 3, and we'll go up to here, we'll call this, say, 8, and we'll call this 9 there. All right, so there's a distinguishable difference between the range values here. One is spanning from 2 to 9, the other one is spanning from 3 to 8. So you have a range of 5 versus a range of 7 for those values. What does that mean? Well, it means that all the values are much closer together. I mean, we could even say, well, what if we take this to the extreme and we move this value all the way like this, and we're talking about it being way up here, maybe at 15 or something. So yes, the median might be higher, but what does that tell us? It tells us that there's less, this is really spread out over here, but this is still represents 25% of the data. Just like here, this represents 25% of the data right there. So this is a much smaller span. So when we talk about the median is halfway in between the upper portion and the lower portion of the data. Here, this upper and lower portion is very spread out. So what does it tell us? Well, it tells us whatever we're studying with these two groups. Let's call this group 1, and we'll call this group 2. Same criteria of whatever else we're trying to study here. What it tells us is that there's a much larger variance with group 2 with this particular scenario that we're dealing with versus group 1. So there must be something out, there must be some factor that causes this wide range of values. Like for instance, let's say we're talking about the growth of an oak tree. And these are the heights of the oak trees in region 1. And this is the height of the oak trees in region 2. Well, why are all the trees, the smallest trees are taller and the largest trees are smaller, and they're all very tightly contained within this region? But over here in area 2, or area 1, we have trees that are enormous and trees that are really even significantly smaller. So what's the difference that causes those events to occur? I'm not really sure myself. I'm not an arborist to know what type of events might cause this to occur, but that's the investigation part of this. And sometimes with data, we're not necessarily looking for answering all the questions, and sometimes we're looking to be able to identify more questions that need to be addressed. In this instance, we're talking about in each of these regions, 25% of the data is in that region. Now, let's talk about the average. Or our mean rather. Where does the average fall in these? Well, these aren't necessarily on these grids, but let's just say that the average, which if we're looking at this is 25% of the data, where would the average fall? The average could fall right here on that area 1, or maybe the average is over here. What does that mean? What it means is, in this instance, if the average is way up here above the median, it means that these values are extremely large in comparison to the other values that we have there. There's an extreme amount of value in there. If we're talking the average is way down here, we're talking about these values right here being massively small. In the other direction, we're talking about it's pulling that average, that mean down because of that value. We still have the same number of data pieces in that region. And in both those situations, it can happen. The same thing can happen here, where we're going to have the mean way up here. It could be inside there. It might be coexisting with the median itself because it's identifying a different aspect of the behavior, right? It's saying if we looked at 100 trees in the region, it means that 50 of the trees are above, 50 of the trees are below that median. But if we looked at the average, what we're doing is the trees that have extreme values here are going to cause a rather big differential in the mean. So that mean is going to be far more affected by outliers. So if we have this one tree way up here that is massive in comparison to all the other trees, that is enough to move the mean from where, maybe right here, maybe the mean, if we take this one outlier out and we throw it away, maybe the average for both of these sets is more or less the same. But if we have that outlier in there, maybe the average moves up to here, and we have this one, that red line, those red lines represent the means. Now that mean has moved up because of this one massive event. So the short here is mean can tell us a lot about a data set, especially when we compare it to median. We should never just look at the mean or the median to analyze a data set, because this tells us about this value right here, this extreme value. Is it an outlier? In this case, it looked like it probably would be an outlier if it's causing this type of movement of the average from it being really close to the median to being in the upper echelon, or if the other was occurring, it was being on the lower echelon, the lower quartile here. That would be a pretty big indicator that that endpoint, those outliers, are having a big effect upon the average, and we need to look at maybe, if we're talking about doing additional analyzation, maybe we think about taking this outlier and throwing it out for a second, and then doing the rest of our analysis just based upon wherever those other values are. Because then, if we do that, maybe it puts the new upper quartile, that new max value, really close to the other max value, in that all of a sudden now we're talking about similar situations just by taking out that one value. Because if we had, this represents 25% of the data, and all of the data is below this line right here, except for this one piece, now we're talking about this one piece causing a lot of disruption to our analyzing. All right, so I hope this is helpful. I hope this is useful. Let me know if you need additional questions or comments about this topic so I can address those as best I can. Take care.